Have you been asked to look into AERMOD modeling? Then you're in the right place.
Hi, I'm Tom Bowman. I created BEEST in the 1980s to make modeling easier. Not only is BEEST the best software, we have the best technical support. And most agencies use BEEST. BEEST will help you manage your modeling project. Let me tell you why BEEST is the best product and how it will help you.
How can BEEST help? Okay, let's start with the basics. AERMOD includes AERMET, AERMAP, and BPIP Prime. These are available free to download from EPA's SCRAM webpage. These are compiled Fortran programs and are run from DOS. Each require an input file and data. This is an example input file that you would have to create using an editor. Before running AERMOD, you would have to assemble the data files, build input files, and run AERMET, AERMAP, and BPIP Prime. BEEST makes this easy. Let's take a look at a project in BEEST. Okay, let's start BEEST, and we'll bring in a file named My Project. This is BEEST's main graphic screen. Here we display all of the different objects, fence lines, buildings, sources. If we need to move something, we can just go to its handle, click, and drag it to a new location. We can add sources also, or buildings. Let's add a building. Let's make the base of the building rectangular. Let's give this building a sloped roof. So here's our building. We will make it a shed roof. We could make it a gable roof. The height of the first level is 10. Let's make the peak of the building 20 meters above the base. And let's give it 3 tiers. And now we select which of the faces of the building, which side is the high side. And we'll go ahead and let it be the red side. So now we'll have it create the tiers, and we can see it in 3D. So it would look like that. Okay, let's keep it. So we'll save that. Now we have our building here. And it's just as easy, we can delete an object. Okay, let's show our objects in 3D. Because we are modeling NO2, here is where we would select the method of ozone reacting with our NO2. For example, OLM requires an hourly ozone file. Here is where we would enter the name for that file. This file was created by our AERMOD wizard program. I'll put a link to this video at the end. On our source options screen, we can add, delete, and edit sources. On the Groups tab, we have defined our project as a group and each of our sources as part of our project individually as a group. Our background of NO2, we have selected temporally varying by season hour. These data came from our AERMOD wizard program. In our receptor options screen, we'll create some receptors, the special grid receptors. We will put receptors around the fence line every 50 meters. We will have a fence line following grid, and we'll have a spacing there of 100 meters, and we'll go out a distance of 200 meters. We'll have another grid spaced at 250 meters that will go out 1,000 meters, and we'll have a corners method. Let me just paste those in there. That will go from these coordinates. Let's generate those receptors. And we'll do an auto scale, and let's put a background grid. That's what our receptor network looks like. Let's look at our output options. We have entered a range of high values of 8 to 13 for NO2 1-hour average. On the Max Decont File tab, we've entered 1 hour NO2, source group all, upper rank 8, and, which represents 98th percentile, and a threshold of 188, which is the NAQS for 1 hour NO2. The Max Decont file tabulates the contributions of each source group to values above the threshold in source group all. We will look at this after we run AERMOD. Let's run BPIP prime. Wow, that was fast. Now AERMAP. We need terrain data. Where do we get it? The data comes from the USGS website National Map. Of course, BEEST has an interface to this site. These are the coordinates we need for our terrain limits. This is the national map from USGS. You would enter the coordinates of the data that you would need, and we can download our terrain data from there. Let's run AERMAP. We've already got our terrain data, so we're ready to go. So this will take about 2 minutes. Let me jump ahead. Okay, we're done. Now we have hill heights and elevations at our receptors. Next, we will run AERMOD. A powerful feature in BEEST is that we can split our run into several partitions. My computer has 4 cores, so I will use 4 partitions. Now we'll run AERMOD. NO2 1 hour is selected as the pollutant, and 2016 to 2020 metadata is selected. Now let's click Include Downwash and run AERMOD. These are the 4 partitions running. We'll jump ahead here. Now we will combine the partitioned runs. Here's our output. the 519 is the maximum from source group all. The maximum from source group project is 93.33. We can display isopleths. We can show radius of impact. Say 7.5, which is the SIL for NO2. What do these results mean? The maximum from all sources is 519 micrograms per cubic meter, which exceeds the NAQS of 188. And the maximum from our project is 93.33 micrograms per cubic meter, which exceeds the significant impact level of 7.5 for NO2. Conclusion: if our project contributes to the exceedance of the NAQS, we cannot proceed with getting our permit. EPA added a feature to calculate the contributions to exceedances with the maxdcont file. This is the file. If we scroll down, we can see receptors that exceed the threshold and the project's contribution. This file is 1,800 lines long and can be much, much longer. BEEST includes a feature to analyze these data and display the results graphically with maxdcont viewer. Let's run maxdcont viewer. Let's zoom in. The values displayed are the maximum values above our threshold of 188. We can see here the maximum is our 519. If we click project, the maximum value for the source group project that contribute to the exceedances of the threshold are displayed. The maximum value is 6.0. This is below the SIL of 7.5. Therefore, we do not contribute to an exceedance. And we can proceed with our permit. What's included with BEEST? AERMOD, the metadata processor, AERMAP, the terrain data processor, BPIP Prime, building dimensions processor, maxdcont viewer, contributions to the NAQS exceedances, partitioning, up to 99 partitions, windrows, array 2, number of exceedances, import, export to Google Earth, ISC ST3, and import AERMOD and BPIP Prime input files. That's a quick tour of BEEST. You've seen many of the cool features in BEEST, but the software is only part of what you get with BEEST. Our users tell us that our technical support is the best. Most state and local air pollution agencies use BEEST software. Finally, you get a bit of me, the old graybeard, and that's a good thing. It's important to me that you get a good quality product and that our service remains outstanding. I hope you'll give us a try.